Hello everyone, good morning.
Good morning, sir.
So let's wait for another 2 minutes and then we will start. Okay, I think we will start. So do you guys have any questions on our previous classes? Yes, okay. So update from my side. So I'm on my way to creating some exercises and all. Very soon I will share those exercises with you. Maybe later in the sessions, we can discuss the solutions. Okay, then so let's continue with our actual topics. So let me share my screen now. Okay, can you guys can see my notebook?
Yes, sir.
Okay, so yesterday we learned about like how we can identify the missing values and what are the imputational techniques, like how we can move ahead. So we already learned about these things, right? How we can do it in Python, how we can fill this with, how we can impute this with mean. We know that, right? What is the mean, mode, median, and filling with any of the keywords, and how we can drop the NS. These are all things you guys already know what it means. But how we can do it in Python? Okay. So now, if you want to drop the NA rows, drop NA. So we have this NA method. Okay. So I will just select the data. Okay. Select the data. Dot. I can use drop NA. Drop NA means it's going to drop the NA rows. Okay. So again, if you go inside of this one, you have this star argument, and as well as axis. By default axis is equals to row. In the level, in row level, it is going to drop the values. Okay, if you provide it as in a one, then what happened? If the column is completely none, then it is going to drop that. This is what it means. Then how threshold a subset in place? I think so. Threshold in the sense, if you are dropping, if your NA values are in the certain limit that you can specify it. Okay, so based on that, it is going to drop the rows. Then subset, in the sense, subset means if you are provided the column name as A, B, C, okay, out of this A, B, C, D, E, then what happened? It is going to check if we have any none rows in these three columns. then only it is going to drop. It is not going to consider the complete row. It is going to consider only those column rows, and based upon that based upon the none values, it is going to remove the complete row. Okay, this is what the subset. And in place, anyhow, you know that what it means, the in place. Okay, if you really wants to understand more on that, again, you can just go through this documentation, and we have some examples as well, and with how it looks. Here it is saying like creation of data frame, how the data frame looks. If I provide it as a drop any, what is the difference that you can see. So here you can see we have none values, and here we have, uh, yeah, here we have NA values, and here is as well. So that's why the remaining row would be, oh, that is one, that is Batman. So if you provide it as a drop NA, this is works as that. And if axis is equals to columns, then what happened? It is going to drop. If we have any none values on that column level, it is going to drop that. And in the name column only, we don't have any NAs, so that's why it is going to taking that. And how you can provide it as a how as well. So if you are provided as how is equals to all, then what happened? It is keep only the rows with at least two non-NA values. If you provide it as an all, so it will keep only the rows with at least two none values. Okay, so that in this way, like subset as well, like in the name and the toy. So it means it is not going to consider the NA of this bar. If we have an NA in that column as well, it is not going to drop that row. So here you can see we have this none, but it is not yet dropped. This is how the argument works. So in place, anyway, you know that. Okay, this is what the argument tells us. So it's our time to check it, right? So let's go with that. So subset citric acid, residual sugar, and chloride. So let's see what are the missing values. Citric acid, residual sugar, and chlorides. Okay, so I'm going to consider these rows. Okay, here we have three missing values, two missing values, and the two missing values. So we don't have any good examples over here for the drop ins, but I'm just showing how we can place, how we can pass these arguments and resolve the non-values problem. So if we are provided that it's just going to remove that rows having the non-values. It is not going to consider for other columns. So let me execute this one. So now you can see the shape of this one and as well as this one. See now, what is the difference? 22, now earlier it is 29. Nearly a 7, right? So let's see what is the count of the non values here. Citric acid 3 and 2 plus 2. It is 5, 7. 7 rows. Exactly, the 7 rows are dropped. It means let me execute this line of code for our clean data. Clean data. So now you can see. So missing values count is 0 here for citric acid, residual sugar, and chloride because we just dropped the NA values. So now imputation for these columns is done. Next, how we can, so again, here I'm just printing it, right? I'll just removing over here. Yep. So now, how we can fill the values with any of the keyword using Python. Okay. So you can just go there and just select the data frame. Select the data frame dot. We have fill NA method. Fill NA function we have. So inside of that, you need to provide the input, the value you need to provide, on which value you should want to fill those things. Okay, again arguments are same as it is. So in place, axis, method. Okay, so fill any. So if I provided a one string like missing, Okay, fill NA with a missing. Then what happened? So I wanted to select some column, right? Mm, I'm just going to select this sulfate. Yeah. So I'm just selecting the sulfate column. Wherever we have any missing values or empty blocks we have, so it is going to have the it is going to fill up with the missing keyword. It's just taking that block and writing missing or whatever you can provide. Okay. So if I run like that, then what happened here, you can see somewhere we have a none. So that's why it is just filling with a missing keyword. This is how you can fill with a missing keyword. Okay. In the same way, so how we can fill the none values with a mean median mode? It is again as simple as that. Instead of that using missing, you can just have the mean values or mode values or median values. How we can find the mean median mode? So just select this data frame and and just select the column whatever it is needed. Just select this column, then dot fill in. Okay, come on. Dot um how we can find the mean median mode? So you can just use a function that is mean or median. You can just replace the missing keyword with that value, median, mean value. First, you need to calculate the median, mean, right? That value you need to fill it. So in this way, you can fill the missing values with the column, with mean. Okay, you can see somewhere we have filled the values within a mean. Maybe here we have a 5.9, 5.9. This values is repeated, right? So I guess this is the mean 7.21. Somewhere we figured it out. Somewhere it is find some none values and it is filled with those values. So let's see. Yeah, we can't see it by our eye by this printing the statement, but it is automatically going to fill up within a mean values. Or if you want to fill within a median, you can use median method. Median method. Come on.
Sir, spelling.
Yes, let's take this. Median, or if it is a what I can say, if it is a numerical, sorry, categorical column, you can use mean, median, or mode. Okay, so you can just fill up with the most repeated values, most frequently occurred values. How we can assign the same results, how we can overwrite the same within our column. So if you did in this way, this is not going to overwrite your data frame. So this is we are applying for each of the column based upon the column, right? Then you need to assign within a column only. So you should not give it only the data frame. No, you just need to assign the column. So you are going to overwrite this column with, because this is a series, right? Whatever we are getting, this is in the series format. In that case as well, you need to provide the uh, variable as in a series only. So you are just overwriting this type column with updated mode column, updated type column. Okay. So far so clear how we can do this one using based upon that situations and all, you can just use this method to implementing the missing values. Okay, if there is no questions, let's go with another statistical thing which you guys should aware of is a data correlations. What do you mean by data correlation? A great aspect of Pandas module is core method, CORR. This is a core method. The core method calculates the relationship between the each columns in your data set. It is going to identify the relationship between the each columns in your data set. What do you mean by the relationship? Do you have any idea about the correlations? I think I have talked a bit on this correlation in earlier. Anybody knows on what it is? No? Okay. So how many of you know the about the data columns, dependent column, or predictions columns? Do you guys aware of those things? Very basically, the in the market, the data available in any of the formats. Okay, so the whichever like however the columns it is, like somehow you will get an 50 columns or hundreds of columns or 10 columns as it is in the in the market. So out of those data sets, you need to identify what are the independent columns, what are the dependent columns and all. So dependent column, always we call it as a prediction column that we need to predict it based upon the independent column. What is the meaning of dependent column? Dependent on the independent column. So let's say if I change, let's say we have an ABC. Okay, I'll just open some Excel file. Okay, here you can see we have an A, B, C, and right. Okay, so we have one. Now we have A. Oh, come on. And here I can say 1 point something, 2 point some values. It's just an example, okay? Okay, this is the data, and here we are having some S, no, yes, no. Okay, so this sort of data you have. Yeah. Mm, mm, mm. So here, can you tell me? So independent columns. So let's say I'm saying that A, B, C is a dependent column and prediction pre is a dependent column. Why? Because if I change any of the values in this row, if I change any of the values in this row, this might change. This prediction value is change. In that scenarios, we can call this as because if I changed any of these values, this will not change. A values will not change, B values will not change. Based on the any values, are we going to change the gender? No, right? Are we going to change the customer IDs or customer names? No, right? Those are the independent columns. Based on their transaction, we can say that this is the sales or these are the good customers or bad customer. Based on their transaction, we are going to identify how the behavior they have, right? In the same way, in the data frame, we need to identify what are the independent columns which we need to take care, and what is the dependent column. It means in the data set, this is our goal. We need to predict automatically. So let's say if A is 1, B is A, and C is 1.03. If we have these values, it means this prediction is yes. If the transaction is good in this row, like quantity of the product, a buying price, and payment method, if everything is in the good way, we need to say that yeah, it is good. If it is in a bad way, like quantity is less, sales is less, the customer is not paying correctly, and this customer is cheater, so then we can say that no, it means the customer is not obeys the rules and all. So based on that, the data engineering people has created a data, but that as a data scientist job is to predict this column by seeing these independent columns, right? So what happened in the machine learning model? So we are going to put this data into the training. Okay. So this data gets trained in beans. It is just going to identify the patterns. Okay. Machine learning models is going to identify the pattern and says that if yeah, okay, if the rows having this values, possible values, yeah, it is going to understand that yeah, I need to predict as an S. Or if I see some other unwanted behavior, unexpected behavior, then it is going to say it as a no. This is what the high level thing you should know about a machine learning models, like how that flow works. So whenever I'm bringing a like what as model training and also this is what we need to do. So by training the historical data, we need to predict it, the future, right? So if I in the next row, if I assign it as an A is 1 and B column is A and C column is 1.08, then our model should predict this as an S. Then because this is follows the same pattern. See here, it's a very small changes. Then in the case it is going to predict as an S. This is what we are expecting. If it is in a B, if the transaction is low, I can say that B is in a low, then it should predict it as a no. So if these values get changed, if this is becoming in a B, if that transaction is bad, then it should define it as a no. So based upon the independent columns, dependent column values getting changed. So dependent column, we can call it as a prediction column. That means target column, and independent columns, we can call it as an independent columns only. So in the data science, we can say that as an this is a X and this is Y. These columns are X, this is Y. Okay, this is a target column, this is a training columns. Clear? Any questions on that? Come on, guys. Are you guys able to follow that or not?
So, Vikram,
Yes.
in all such cases, there will be only one dependent column. Or it can be more than one.
So you need to decide it, like in the situations, okay. So in the market, you will get in a columns having an 100, okay, for the sales prediction. So you need to select the columns first and you need to take the data. Okay. So based upon that, what you need to achieve? Are you going to predict the customer is bad or good? Are you going to predict the sales? So what you want to predict without without any human interaction in like in future, that you need to decide it. So based on the decision, you can call that, you can take the target variable, that is dependent variable. Tell me now, sales is dependent on what are the what are the columns? Maybe it is depending on the quantity of the product, price, and what is the actual price it had, and whether the person is payment is good or not, right? Based upon all this transaction, the sales value, sales decision is going to take, right? Sales is good or not. So in the same way, so if we are going to enter these values in future, then machine is directly going to identify this transaction is good or not. So in this way, you need to think and you need to select the columns. In future, in the data, absolutely you have a multiple dependent columns as well. But you need to take which column you need to predict. Okay. Did I answer your question?
Yeah, I've got.
Yeah. Okay. Somehow it's in some cases. Okay. So we have I think, do you guys aware of categories of machine learning algorithms? Maybe in future, in this class only, you will got to know what is the difference. But I'll just tell that what is the high level overview. If you seen this kind of data, we can call this as supervised learning. So we have three set of categories in the machine learning: supervised learning, unsupervised learning, and time series. Okay. So if we have a dependent column and the independent column, we can call this will consider it under the category of supervised learning. If your data set having only the independent columns, there is no dependent column. If there is no dependent columns, then we can call it as an unsupervised learning. Time series, it is only depending on the forecasting data. Okay. If like in future, what is the sales curve for in the next 2 years, for in the next 1 year, what is the prediction? So that we can call it as a time series data. Okay. In supervisor, we have two categories. That is, one is classification and the regression. So we will get to know all of these machine learning algorithm techniques in future of this training sessions. Okay. Just I wanted to highlight about this data. Just that's why I just bring this concept. Okay. So now, okay, here only we can discuss. Now I need to identify correlation. What is the correlation? Correlation means it is nothing but it is going to find the relationship between the one and the other columns on our data sets, right? Then if I say A is most related, having a good relationship with a pre. A is having a good relationship with a pre. What it means? Now it's time to select the what I can say of good features. So like this, if I have 20 columns, like this, I have 20 columns. I wanted to refine those columns. So we just refine some rows, right? We just remove the duplicates, none values, all these things we did it, right? In the same way, we should also do for the columns, right? I don't want to pass all the columns to my model training. I wanted to pass only the good and most important columns for my prediction. So my prediction here is prediction column is pre. This is my target column. This is my independent columns. Okay. I wanted to select a good columns out of that. So now if I say A is good relationship within a pre, what it means? And B is good relation, B with the pre having a bad relationship. Okay. And C with the pre is good. So now tell me on this chart, in general, A is having a good relationship with a prediction column is a good relationship. Do we need to consider this column or not? So it's a common thing, right? If prediction is good, if you have a good relationship, it means this column is very much dependent on this column. If the A is changing, this prediction getting changed. It means this A is affecting more on this prediction. It means we need to consider that column, right? If it is affecting our target column, we need to consider that. Based upon that, it is going to change. It means this A is a most important column for my prediction. If yes, I need to select that. I need to consider that. If it is bad, so the relationship is very bad over here. from B to this prediction column. This is very bad. In that case, what it means? It is not passing any good information for my prediction. Then why need to take that? It is not impacting. So then you can just remove it. Then you can just consider that I don't need this column for my prediction. Then if we have a good relationship with an C, then we can take that. So ultimately, what is the statement we need to put? If the variable is highly correlated with the target column, then we should consider that column for the prediction or model training. If we don't have any good relationship with the target column, then we need to remove that column. Then we should not consider that. Right? This is what the statement of this chart. Now, another thing is, so now we are just comparing, we are just finding a relationship with a prediction column. Now, other ways we need to find the relationship between the one-on-one of the independent columns. So what are the independence column? A and B and A and C, or B and A and B and C, and C and A, C and B, right? So let's take that combination A and B, A and C, right? Then B and A, it is already there, this combination, then B and C. B and C. Then C and B, it is already there, C and A is also there. Okay, so here we can say that here we have a good relationship. Yeah, and good relationship, bad relationship. Here we have good relationship. Here we have a bad relationship. Okay, now tell me, if I said A and B have a bad relationship, if both are bad relationship in the sense both are different, right? Then do we need to take that column? Do we need to consider both of these columns?
No need. No.
No. Do we need to consider these two columns for model training?
If it is bad, generally we don't need.
If it is bad in comparison with the prediction column, if you are finding a correlation, that is the relationship between the independent column to prediction column, if it is good, then it can take. If it is bad, don't take it. Why? Because this is not at all affecting, right? This B is, it means why we need to take that. So this is not at all important for my prediction. This B, if it is bad, means B column is not important for the prediction. So that's why I'm removing. But here the situation's changed. If we have if we have a bad relationship in the sense, this column is different, this column is different. A and B is in a different column and passing the different information for prediction. Then I should take both. It means informations are different. So that's why I need to take that. If A and C is, if A and C is good relationship, if A and C have a good relationship, what means both are same. If it is a good relationship, both are same, passing the same in, like these two columns are passing the same information for my prediction. Then why I need it? Can I take either one of that, right? I can take either one of that. If it is bad, again, I can consider it. So ultimately the statement is, if the relationship between the independent columns is good, then we need to remove either one of those columns. If it is bad, we can consider both the columns. So any questions or any confusions you have?
Sir, a small doubt. Who will decide if it's good or bad? Who will decide the correlation between the columns?
It's data scientists. So now we need to find it. So this is what's the correlationship things. Okay. So now we need to find out how we can find the relationship between these columns. We can't see it, right? Whether it is a good information or not. We need some statistics for that, right? that statistics we can call it as a correlation. How we can find the relationship between the one another? So we need to find the correlation. So I'm not going to explain the inner mathematics of the correlation. That's again a big statistics behind that. By Pandas is just giving one function having all the backend calculation. That is nothing but core function. Core function. From this core function, we'll get one chart with the relationship values. The values is lies between 0 to like -1 to +1. The values as lies between -1 to +1. If it is the values is very near to 1, from 0 to 1, right? You can just consider middle point is 0. Skip A. -1, 0, 1. Okay. So the correlation values are lies between -1 to 1. Why? Because it is not going to say like yes or no. It is not going to say bad or good. Based on the values, as a subject matter expertise, we need to take the decision whether it is good or bad. How we can take that? So it's just going to give the values. Means if it is 0, the correlation value, then we can say that correlation is less. Then it means we don't have any correlation between those two columns. If the correlation value for those two columns is 0, it means there is no relationship between those columns. If it is going to reach this 1, let's say if you have a correlation value 0.1, 0.2, 0.3, then it is some deviating. Somehow have some difference. Somehow have some relationship between those two columns. If the column A and column B correlation values lies in 0 to 1 in the value of 0.9, wherein 0.9 is very near to 1, right? If the value is correlation value is 1, they can call it as both the columns are same. Both the columns are same. If it is very near to 0.9 or 0.8, somehow they are passing in a same information. Then also we can take the decision of dropping either one of the columns. Okay. If the correlation value is reaching +1, then we can call it as a positive correlation. If it is going to reach on negative values, then we can call it as a negative correlation. If it is positively affected or negatively affected, we are just going to drop either one of those columns. This is what we should know. Okay, but be careful on that. If you are comparing with a dependent column to independent columns, the statement is different. If you are comparing only the independent columns, again the statement is different. Okay, now let's identify correlation between some of the data. So for that, I just downloaded one of the data, okay, having some correlation, some good, like passing some same information. So you can get the correlation for any of the data. That is not the problem. So I'm just reading the data frame. I'm not doing any of the calculations over here. I'm just calling this core function. Data frame dot core function. You can just execute this line of code. So now you guys can see this chart. Okay. Duration, you can just compare it within a probabilistic way. We can just compare it, this columns with this index or this index with this columns, both are same. Okay. Duration to duration. These two columns are same, right? That's why it is showing it as a correlation value is 1. If it is 1 means both the columns are same. Yes, that is correct. Duration and duration is same. Both the columns are same. So let's compare with other columns. Duration with pulse, max pulse, and calories. These are all the independent columns. Okay, there is no dependency. So in this case, if the correlation is high, we need to drop that column. Let's see duration and pulse. What is the value, correlation value here? It is from this chart, it is -0.1. Then it is okay. 0.1, it is less only, then it means we don't have any relationship. Let's consider other one, 0.009. Yeah, it is much different. So this is also okay. Now let's see duration and calories. It is 0.92. 0.92. It is very, very near to 1, right? It means, what it means? It is highly correlated. Duration and calories are highly correlated. Then I need to take either one of that column. In the same way, if you want to check other one, you can see pulse to pulse, it is 1. Pulse to pulse, both are same. And pulse to max pulse, you can see. Pulse to duration, you can see. And pulse to calories also you can see. So 0.7, this is also a big number. Okay, again, we need to select the threshold values on which level you need to consider the correlation values, whether you are going to consider the value above 0.8 or 0.9 or 0.7, that you need to consider. Based on that values, you need to select the columns to drop. You can just refine the columns. This is what we can call it as a feature selection. The correlation, finding the correlation and selecting the columns is also one of the feature selection techniques. Okay. Any questions so far on this case? So you can just drop either one of that column. You know, right, how we can drop the columns. Here we have just whatever I explained. I have just written it in the statement, maybe in the notebook as well. You can find it. With this example, I just explained what is the relation and all. What is the meaning of perfect correlation? What is a good correlation? What is bad correlation? I explained everything over here. So far, so clear? Any question? Actually, guys, this is an important and very tricky one, I know. But you should aware, like if you understand the concept, that doesn't make difficulties for you.
Do we use more in the real scenario?
Yes, we are using this correlation in all the scenarios. This is one which you definitely need. If you got the data, once you clean the data, then you need to check the correlation. If we need to check it, if we don't have any correlation for this independent column, then you can take all the columns. But we need to check it. It's our job. Okay, so for that only I just created, that is actually a feature selection technique with the correlation. I just added, I just created this notebook. I will share this notebook with you maybe after this class. So here I just created a one data frame. So you can see with all the numerical values, you can easily find out a correlation for the numerical values. And future matrix. Okay, so here you can see MEDB. This column is what I can say, prediction column. Y column means dependent column. So if we really want to just only take in a relationship between only independent columns, so that's why I take it as an X. X means these columns. Y means target column. That's it. This is what this code tells. And yep. And you can use scikit-learn. Maybe you got to know about the scikit-learn once you entered into a model training section like machine learning. So after this Python classes, you guys joining into our statistics classes. After the statistics, we are jumping into that machine learning algorithm. This is what the plan is. But until that time, you can just have a look into this scikit-learn library. So in later classes, you will get to know what is the meaning of the scikit-learn and all. Okay, it's just a library. So from this side library, I'm just splitting this data set. So splitting this data set means, okay, somebody texted, how many classes of Pythons are remaining? That I can't show because maybe it will take another week or so. Okay, this is all about how much understanding you guys are getting. Okay, so now splitting the data set, it is nothing but splitting the data set in the two data frames in the row level, not in the columns level. It means 70% of the data in one data frame and 30% of the data in one data frame. So that we can call it as a test and a train. So in the model training, we are not pushing complete data frame into a model training. We are just splitting the data frame into two parts. One is test and one is train. So 70% of the data we can call it as a train data. 30% of the data we can call it as a test data. 70% of the data is going to train and 30% of the data will remain the same. So then we are going to test our model on the test data, whether it is working fine or not. Okay. So now we are just splitting into train and test. So test size is 0.3. So this is what X and Y we are providing inside of the function. This is X and Y we are providing. And the random state, we are just fixing that while doing in a splitting to avoid the shuffles, we are fixing a random state. So test size in the sense, what is the difference you need? Where do we need a 30%, 70% or 40%, 60%? That you need to define. If I defined it as a 0.3, it means it is a 30%. Okay, 30% is the test data. Rest of remaining one is 70% only. So that data is in train data. Okay, you guys can see that out of this 500 rows, nearly around 500 rows, we have 354 rows here and 152 for test. Okay, so I'm just taking a correlation in the test data set. You can see the correlation values. Is it possible now to identify each and every column? So how we can go here? Yeah, so now we can see this chart. Is it possible to identify by going each column? CRIM, yeah, we have a good correlation because both are same. CRIM, ZN. So it is very hard to go and compare with each and every columns, right? So for that, we need to create one functions, right? The function should be compare these two columns, compare these columns, and if the value is greater than of some threshold values, we need to consider that column, either one of that, we need to drop it. This is what the concept is. That based on that concept, so you can see, so we can just plot it in a visual, we can just see in a visualizing way also. You can see if it is very near to this black color, then we can say it as a very near to black color, and this blue color, we can say it as it's a correlation, right? So you can just check that value. So you can see the color, I can easily go here, that is 0.5. What is the values? That is NYX and Indus. So it means both are passing the same information. It's also a good correlation. In this way, you can identify. Okay. So again, it is not possible by the human eye, like if the variables is 50 or 100. For this 10 variables only, we are just struggling this much, right? For the more than 50 columns, it is not possible. So for that, we need to simplify the process, right? So for that, I just created a function. I think you guys got to know like how we can create a function. This correlation function accepts the data frame and as well as threshold values. Threshold values in the sense, so if it reaches on which values, we need to select it is a good correlation. Right now, if we select it as a 0.9, so it is going to consider the variables who have the correlation value 0.9 greater than 0.9. So based on that, we can provide it. As for that user convenient, I just provided this argument. They can provide it. So here I'm just creating an empty set to store all the variables, correlated variables. Okay, I just created a correlation matrix. So I just created this correlation matrix by calling dataframe.core. Okay, now it's time to check. It's time to check it, right? So I'm just using the for loop, then considering these columns and the for loop to check each and every variable and comparison. Okay, so I'm just taking in a ABS because we have a negative correlation as well, positive correlation as well. So, but I need that values, whether it is a positive or negative. If it is a values is very closer to 1, it is correlated value. So that's why I'm taking it as an ABS. It means positive or negative values also gets converted into positive values. So we are interested in absolute coefficient values only. Okay, so and we are getting the column names and attaching into that set and attaching into the set. At the end, we are just returning that sets only. So let me execute this function. Okay, I need to execute from the beginning. Okay, forget about this one. After that, I need to split the data frames. What happened? They are saying X and Y is not there. I need to execute this line of code. This one. Splitting is done. The function call is also done. Now I can use this function. Okay, instead of printing all this chart and all, I just need a column name, right? The columns which are correlated. Correlation, I can pass the data frame that is X train maybe. Yeah, X train. The threshold value which I am setting is 0.8. If it is greater than 0.8 correlation value, just select that. So I'm just executing this. See this tags. You can see this tags is the column which is highly correlated. Maybe, yeah, here you can see that is 0.9. It is greater than that. So tags and RAD is highly correlated. So it is just removing the either one of that. Okay, if that RAD is come first, then that's why it is just keeping that tags is going the next. Either you can keep RAD or text. So it is saying that to remove this tags column from the data frame. Okay, if I selected this as then a 0.7, maybe we will get some more columns. Age, DIS, NOx, tags, age. Let's see in the age. So do we have the values greater than 0.7? We have yes, 1, 2. Yeah, we have 2 values, right? Either one of that it is going to remove. So in this way you can identify. So instead of going to see and chart, this function will help you to identify the columns. So it means we need to remove these 4 columns from the data frame to avoid passing the same information for my predictions. Yeah, this is the magic which you could do if you know the basics of Pythons. So here, everything is basics of Python. The for loop, absolute function, sets, the data structures, and data frame operations, everything. Right? So, do you guys have any question? I will share this notebook right away with this data and as well as this notebook. Okay? You also get understanding what it says. Any questions so far? This is the data set from the library itself, from the scikit-learn library. Okay, so just I'm reading that. So this is not from any of the source. You can just directly read it from this library. Library is also providing some example data sets to understand. That is load boost on data set. Okay, then if you guys don't have any questions, so let's pass this class for today. Let's continue in tomorrow sessions. Okay, then take care. Have a great day. Bye-bye.
Thank you, sir.